All right, it's time to do a couple of practice problems, and I would like you to go ahead and pause this video and try to match the graphs on the left, which are the graphs of the functions, and then the graphs on the right, which are the graphs of the derivatives. I'll go ahead and let you pause, and then you can come back and check your answers. All right, this first graph A matches the derivative in 3, and that is because, first of all, there's a break in the domain of A on the y-axis, and that matches in 3. Plus, both branches of the function have both branches are increasing, which means that the derivative is always positive, which happens here in 3. In B, we have a concave down function everywhere, so the derivative must be decreasing everywhere. And the function goes from increasing to decreasing, so the derivative needs to go from positive to negative. That matches 5. We have a decreasing derivative that goes from positive to negative. C is going to match number 2. It has 1, 2, 3 horizontal tangent lines, and therefore 1, 2, 3 x-intercepts. Furthermore, the function goes concave down, concave up, concave down, so the derivative should go decreasing, increasing, decreasing. D might be the easiest one. This is just a line with a negative slope, and so its derivative has to be a constant that is below the y-axis, or below the x-axis, excuse me. So that's number I. And then last, part E, this is an upside down absolute value function. So a positive constant slope on the left and a negative constant slope on the right, with a break in the domain of the derivative at x equals 0 because of this sharp point. Now this next problem asks us to draw a continuous function that satisfies all of these criteria. So where x is less than 2, we want the function to be increasing because the derivative is positive. So that means f is increasing on this interval. Then we want the derivative to be negative between -2 and 2. That means that the function is going to be decreasing. And then last, we want to have a horizontal slope on the function where x is greater than 2. So we basically want an increasing, then decreasing, then constant function. And that's all the requirements that we have. So where x is less than -2, we want an increasing function. And then between -2 and 2, we want a decreasing function. And then starting at 2, we want a constant function. And actually, the placement, the y-value placement, or the extremes of this really don't matter. You just need to make sure you go increasing, then decreasing, and then constant.